I have one more example for us where we'll consider how mean and medians change or don't change when data changes. This is very similar to one of the homework problems, and I thought we should probably go over it in lecture before you face it in the homework. Consider a data set with 5 distinct data values. That word distinct is indicating that they're all different from each other. Suppose the mean is A and the median is B. If the highest number were increased, what would be the effect on the mean and the median? If the highest number were decreased to a value that was still larger than B, the original median, what would be the effect on the mean and the median? If the highest number were decreased to a value less than B, the original median, what would be the effect on the mean and the median? I think the best way to explore this question is with an actual data set, so we'll just make one up. We'll use 1, 2, 3, 4, 10. The mean, which this problem is calling A, so that's the original mean of the original data set, would be 1 plus 2 plus 3 plus 4 plus 10 divided by 5, which works out to be 4. B is this problem's name for the original median. And since our data set is presented in numerical order, the one in the middle will be the median. So that's our B. Now in part A of this problem, it asks us to consider what happens if the highest number was increased. So let's change the data set to 1, 2, 3, 4, 100 and see what happens. The mean now is 1 plus 2 plus 3 plus 4 plus 100 divided by 5, which is 22. The median of our new data set is still 3 because 3 is still right in the middle. So increasing that highest data value increased the mean by quite a lot. The mean went from 4 to 22, but the median stayed the same. So this is another example of the mean being sensitive to changes in data values where the median isn't necessarily so sensitive. Part B of the problem asks us to consider what would happen if the highest data value in the original data set, so that 10, was decreased but not decreased below the original median 3. So let's say that 10 decreases to, let's say 5. So that's a decrease, but it hasn't been decreased below B, the original median. Now the mean is 1 plus 2 plus 3 plus 4 plus 5 divided by 5, which happens to be 3. The median, however, is still 3 because 3 is still the number in the center of the data set. So decreasing the highest data value caused the mean to be decreased from the original mean of 4. However, the median stayed the same. In part C of the problem, we're asked to consider what would happen if that highest data value of 10 from the original set was decreased to a number less than the original median of 3. So let's say that 10 decreased to a 2, so it's now less than the original median. So our data set now looks like 1, 2, 2, 3, 4. Now the mean is 1 plus 2 plus 2 plus 3 plus 4 divided by 5, which is 2.4. So again, decreasing a data value means the mean gets decreased. What is our new median, or what is the current median? Well, now the number in the middle of the data set is 2. So our new median is 2. So this time the median decreased. So it's not that changing the data values won't do anything to the median. If you change a data value enough that the middle is in a different spot, then that will affect the median.